Alright, in this video we're going to look at solving systems of linear equations using linear combinations or the elimination method. Hopefully you've watched the other two videos on this already, so this is kind of the third in the series. So here's the system that we're going to try to solve this time. So we have 2x plus 3y is 4, and 5x plus 2y is 6. So the problem that we have here, which is different from in the previous videos, is there's no easy number that I could multiply the top equation by to cancel out with the bottom equation, and there's no easy number for the bottom equation. So what I'm going to end up doing is I'm going to multiply both equations by something and create a totally new system that's really just a scaled up version of this one, where I can cancel one of the variables. So what I'll do is I'm going to focus in on the y coordinate, or the y variable, multiply the top equation by 2. So if I multiply the top equation by 2, the coefficient of y will be positive 6. So what I want to do is multiply the bottom equation by something so that I will cancel that out when I add them together. So I have to multiply by negative 3. So you'll notice that what I did was I basically took the coefficient of y in the bottom equation and I multiplied the top equation by that. So I multiply the top by 2. And then I take the bottom equation and I multiply it by the opposite of the coefficient of y in the top equation. And that forces them to have opposite signs but be equal. Equal and opposite. Not really equal, you know what I mean, absolute value. So what I'll do now is just kind of work that out. So 2 times everything on the top gives me 4x plus 3y equals, 4x plus 6y equals 8. Almost forgot to distribute. And then I'm going to multiply the bottom equation, everything I see, by negative 3. So I get this, which will give me negative 15x minus 6y equals negative 18. So what I'm going to do is I'm going to combine those into a new system, which is really just a scaled up version of our old system. So I have that. That creates the equal and opposite coefficients that I wanted. So I have this, and what I'm going to do is add them down. So if I add, I'll get negative 11x, the y's cancel, and then negative 10. I'm going to divide through by negative 11 and get x is 10 over 11. So now I do the same thing that I've done in every case, where I go back to the original, pick one of them, and I'm going to substitute in. So I'll pick the top one. So I'm going to replace the x with 10 over 11. 2 times 10 over 11 plus 3y is 4. So that's 20 over 11 plus 3y is 4. Subtract 20 over 11 from both sides. Now on the right hand side I need a common denominator, which will be 11, so 44 over 11 minus 20 over 11. Simplify that, running out of space. So I have 3y is 24 over 11, so that's y is 24 over 33, but I can simplify that because there's a 3 in everything. So y is 8 over 11. So x is 10 over 11, y is 8 over 11, or I could write it as the ordered pair, 10 11ths, comma, 8 11ths. And that's the problem. So in this case, a little different. I had to multiply the top and the bottom equation by something. And what I did was I looked at the coefficient of y in both equations, and I kind of used that as my guide. So if I had multiplied the top by 2 and the bottom by positive 3, they wouldn't have canceled out. So instead I multiplied the top by 2 and the bottom by negative 3 and just changed the sign of one of them. And it works out. So I hope you found this helpful, and good luck.